Hello everyone, I'm Wang, and we're glad to be here to present our work StickyLand, which is a collaboration between me, Katie Dai, and Keith Edward from Georgia Tech. So over the recent year, we have seen a booming of the field of data science, and according to a Kaggle survey in 2021, computational notebooks such as Jupyter Notebook and Jupyter Lab have become the most popular programming environments among data scientists. Actually, more than 3/4 of the survey data scientists use those tools. So what are computational notebooks? So you can think of them as documents including many different cells. Well, the cells can be markdown text where a user can render, or some programming code where a user can run and see the output immediately after the code. According to a recent survey, there are many limitations or pinpoints of those computational notebooks, such as it's very hard to organize the code in the notebook, very hard to see the running history of different codes, and the code probably not very product ready after running the notebooks. And in this work, we focus on the first limitation, is the code organization. Researchers have identified there is a mismatch between the linear presentation of the cell in the document and also the nonlinear data analysis workflow. To help improve the code organization, we designed and developed StickyLand, which is a Jupyter Lab extension that can empower the user to organize their code in computational notebooks in nonlinear ways. And here I will give a demo of this tool. To run StickyLand, user can click the button on the toolbar, so we can see StickyLand stick on the right edge of the notebook. User can reposition and also resize the StickyLand panel. User can drag and drop to create new sticky cells. The sticky cell are a clone of the cell in the notebook, and the content are synchronized. User can also run the sticky cell directly in StickyLand. User can also change the variable in the main notebooks, then the visualization will be updated accordingly. User can also drag and drop to create sticky markdowns, and user can edit and render the markdown cells directly in StickyLand. User can also create a brand new markdown or code cells directly in StickyLand. And after closing those cells are displayed again in the main notebooks. An interesting feature is user can automatically run the sticky cells. For example, here we have 4 functions. The first one loads a random image from the dataset, and the second one rotates the image, the third one adds noise of the image, and the fourth one corrupts the images. Let's create 3 sticky cells for those 3 functions, and we turn on auto run features. Every time the user loads a new random image, you can see the cells are run automatically. User can also make the cells float on their notebooks. So for example, here we create many sticky cells. Then we click the launching button, so we can launch a floating cell of the sticky cells. User can resize and reposition the different floating cells. And with multiple floating cells, you can see we can create an interactive dashboard. So for example, here we use auto run feature to create an interconnected dashboard and use visualization to improve machine learning model. To learn more about StickyLand, please check out our research paper. StickyLand is open source, so be sure to visit our GitHub repository. You can also try out StickyLand and use pip install in your computer. Thank you so much.